Today we are walking through the paper titled From AGI to ASI.
What question is the paper trying to answer first?
It asks what might happen after human-level AGI exists. The authors do not treat AGI as the final destination. They ask whether AI progress could keep moving toward artificial superintelligence, and what could speed it up or slow it down.
So AGI and ASI are not being used as vague hype words here.
Right. AGI means roughly median human-level performance across most cognitive tasks. ASI means much more than one superhuman tool. It means general intelligence that outperforms large, well-coordinated groups of human experts across virtually all important domains.
Why do the authors think artificial systems might move past human collectives at all?
Their key reason is that digital intelligence scales differently from biological intelligence. An AI can be copied exactly, paused, resumed, run faster, run in many instances, and share digital experience at high bandwidth. Those advantages become larger as compute and hardware improve.
Does that mean ASI would be unlimited?
No, the paper is careful about that. ASI is not omniscient or omnipotent. It still faces physics, real-time, physical manipulation, observability, complexity theory logic, and the limits of computation.
How do they put a theoretical ceiling above ASI?
They use universal AI, also called AIXI, as the formal upper-bound picture. AIXI is an ideal agent that plans under uncertainty over all computable environments. It is incomputable, so it is not a buildable system, but it clarifies what perfect general machine intelligence would be optimizing toward.
Then what is the actual proposed framework of the report?
The report organizes the AGI to ASI transition into four possible pathways. They are not mutually exclusive: scaling, algorithmic paradigm shifts, recursive self-improvement, and large multi-agent collectives.
Start with scaling. What would have to keep improving?
Scaling means continuing the pattern behind recent AI progress. More compute, larger or better trained models, more data, better hardware, and better algorithms. The paper notes that effective compute has grown through hardware improvements, larger investments, and algorithmic efficiency.
What could make scaling fail before ASI?
The clearest friction is the data wall. Human-generated text cannot grow as fast as model and compute demands. The authors say synthetic data, simulations, self-play, and interaction data might counter this, but naive training on self-generated data can plateau or degrade.
Is data the only scaling bottleneck?
No. Continued scaling also needs money, chips, energy, data centers, memory bandwidth, and interconnects. If capability gains depend mainly on raw scale, those resource demands could become a major bottleneck. If algorithmic gains keep reducing cost, the bottleneck could be weaker.
What is different about the paradigm shift pathway?
This pathway says the current recipe may evolve or be replaced. Today's recipe is large pre-trained transformers. The paper says AGI may need additions like long-term memory, continual learning, robust planning, and better world models.
Why is that pathway harder to forecast than scaling?
Scaling has historical curves to fit. True paradigm shifts do not. A new architecture, a new training objective, or a new hardware style could change data efficiency or energy efficiency. But the report argues that the timing and impact of such shifts are intrinsically hard to predict.
Now explain recursive self-improvement.
Recursive self-improvement means AI helps improve future AI. That can mean writing better algorithms, designing better chips, creating better training data, running experiments, or improving how AI collectives divide labor. Better AI then improves the next round of AI research.
Does the report claim that this creates an immediate intelligence explosion?
No. It says the dynamics are poorly understood. Recursive loops could accelerate sharply, but they could also taper out. Even digital researchers need time, compute, energy, hardware, and experiments. Physical world steps cannot be sped up without limit.
What about the multi-agent pathway?
Here ASI emerges from groups, not just from one smarter model. Many AGI agents could specialize, communicate at high bandwidth, split work, and coordinate through centralized plans or decentralized markets. The collective might solve problems that no single agent can handle.
What is the open question for groups of agents?
The open question is how group intelligence scales. Bigger groups need more compute and coordination. Human organizations gain from parallel work in diverse skills, but also suffer bureaucracy. The report asks for multi-agent scaling laws that measure when AI groups improve linearly, superlinearly, or with diminishing returns.
The pathways are clear. What is the most concrete limitation the paper highlights beyond ordinary resources?
One important idea is the abstraction barrier. Current models learn from human-made symbols and concepts. The concern is that they may recombine what humans already discovered without forming genuinely new conceptual primitives from our physical experience.
What example makes that limitation intuitive?
The paper asks us to imagine training a modern foundation model only on pre-Newtonian scientific knowledge, without concepts such as calculus, universal gravitation, or electromagnetism. It is not obvious that the model could reason its way to relativity or quantum mechanics from text alone.
Does governance appear as a technical bottleneck too?
Yes, the report treats deliberate slowdown as a real pathway friction. Accidents, misuse, military pressure, labor disruption, public backlash, or regulation could cap development even if further scaling is technically and economically possible.
What are the paper's main findings after weighing all of that?
The main finding is not a single date or a prediction. It is a map of uncertainty. The authors argue that progress beyond AGI could accelerate through several parallel mechanisms, and that no currently discussed friction is settled enough to rule that out.
What should researchers measure next?
The agenda is practical. Improve forecasting of compute, data, energy, and economic limits. Build benchmarks that work beyond human expert performance. Track how much AI accelerates AI research. And develop scaling laws for recursive improvement and multi-agent systems.
So what should a viewer take away from this report?
The takeaway is that AGI is not necessarily one final step. It may be the start of a new phase where scaling, new algorithms, self-improvement, and agent collectives interact. The responsible response is to measure the frictions early, because waiting for certainty may mean waiting too long.
That makes the report less like a forecast and more like a checklist for reducing uncertainty.
Exactly. It says we can only see a short distance ahead, but there is already plenty to measure, model, and prepare for. That wraps up this paper walkthrough.